the binomial distribution. Many types of probability problems can be only two possible outcomes, or they can be reduced to two possible outcomes. You see the word bi, you guys know that that means two. So a binomial distribution can be reduced to two possible outcomes. Now, that does not mean that there's only going to be two x values, but it just means that there's going to be a success or a failure. So, for example, when you toss a coin, it can either be heads or tails, right? Okay? And if I say, well, it's a probability of getting a head would be a success, the other one would be getting a tail. So you have two outcomes there. Getting a baby, you can either have a boy or girl. And these ones have 50-50, but there's some other things that are two chances that are not always 50-50. So, for example, it could rain or not rain. And those don't have a 50-50 chance each. But you have a lot of probabilities that you can reduce down to two outcomes. Either it happens or it doesn't happen. That last one that we just did, either you win or you lose, right? They didn't have equal probabilities. It wasn't a 50-50 chance, but you either won or you lost, right? So a lot of probability problems can be reduced down to two outcomes. There's 4 criteria to be a binomial. One, there has to be a fixed number of trials. Okay, so I'm going to put a little dot here. I don't know why the bullets didn't show up on here. So there has to be a fixed number of trials. So we have to know that we're going to try playing like 10 times, or we're going to play the game 20 times, or we're going to have 5 children with the boys and girls. There has to be a fixed number of trials. We have to know how many times we're going to do it. Each trial has to have only 2 outcomes, okay? So to be binomial, you have to have 2 outcomes. There has to be a fixed number of trials. And the outcomes have to be independent of each other, okay? What that means is the one does not affect the other. So when I was just talking about that last one where we were rolling the dice and trying to get doubles, every time you roll the dice, they're totally independent of each other. The dice does not remember what it did on the last try, okay? Every time you have a child, it's totally independent. Whether or not you have a girl the second time does not depend on whether or not you had a boy the first time. Your body does not remember what it had, okay? They're totally independent from each other. Flipping a coin, every time you flip a coin, it's independent. Okay? The coin cannot talk to the coin and say, oh, last time you did a head, this time you should do a tail. Okay? They're independent. So the outcomes have to be independent of each other. And then one more thing, the probability for each success has to remain the same for each trial. So what that means is every time you do it, it still has to have that same probability of happening. You can't change the probability every time. So every time you have a kid, you still have really a 50-50 chance of having a boy or girl. Or every time you flip a coin, there's always a 50-50 chance. Or every time you play that one game, what's your chance of getting doubles? It's always a 1 in 6 chance, right? It doesn't change from time to time. That probability stays the same for every trial. Okay, these are just vocabulary words. P of S, that would make sense for probability of a success, right? So you'll see that, P of S. That means probability of a success, probability that a success is going to happen. That does not mean probability times success. That means probability of a success. P of F would be probability of a failure. Lowercase p is the number of probability, the numerical probability of the success. So this is like the symbol, and this is an actual number. So I sometimes tell people that P of S is actually equal to little p. Okay, that's the probability of success, and Q is the numerical probability of the failure. So P of F is actually Q. The probability of a failure is your Q number. Did we use P and Q before in this class? No? Okay. P and Q have to always add up to 1, because the probability of a success and the probability of a failure always have to add up to 1. So what you're going to notice here is they have probability of a success is P, probability of failure is 1 minus P, which is Q. In other words, P and Q have to always add up to 100%. Okay, you got success and failure. You got 2 outcomes. You only have 2 values. Okay, and then N is the number of trials. Obviously, we've used that. And X is the number of successes in N trials. So I want you to write that down, that X is your number of successes. And so X could be 0, 1, 2, 3, all the way up to N. X will always start at 0. Okay, are you listening to me? X will always start at 0 because you might have no successes. You might have 1, 2, 3, 4, 5, all the way up to N. So X will always be 0. X will always start at 0, sorry, and go to n. Okay, here's the longhand formula to find each probability. How many of you guys want to type this in with all the factorials and the exponents? Okay, if you do, great, follow the formula, plug everything in. If not, you go and you ignore that, and you grab your graphing calculator and you find the thing that says binomial PDF, and all you have to do is type in NP and X, and it will, again, accurately do that for us. Now, why are we finding binomial PDF? What do you guys think this stands for? Binomial, probability, distribution, and then the F stands for function. So binomial, probability, distribution, function. I'm curious who can find that on their calculator, where it's at. Okay? So if you search around, can you find where it's at? You're finding something that says binomial PDF. And this is a probability distribution. And so you're probably looking under the stat button, right? It's not in the stat button. There's another button on our calculator. I'll give you a hint. Find this on your calculator. You got to find the thing that says distribution, D-I-S-T-R. So you look on your calculator a little bit. It's right over here, right above the vars button. Okay? So second vars. And as you scroll down through these, you'll find it. It's right down here. Okay? You don't see it right away. You got to scroll down a little bit. So we definitely probably need to write that down on the sheet because we're going to forget, okay, where that's at. But it's second vars, and then you have to scroll down. On mine, it's letter A. I think pretty much everybody's it's letter A, but I can't guarantee that. Okay, so second vars, and that's the distribution button. And then scroll down to letter A. Okay. So we could jump right into the examples, okay? So this says, a survey found that 1 out of every 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month, okay? So right now, let's figure out what the probability of a success is. A success means you visited the doctor. What's the chance you're going to visit a doctor? What does it say in here? 1 out of 5, okay? 1 out of 5 people. So that's our probability of success. That's our little p. P is 1 out of 5, or 20%. 1 out of 5, or 0.20. I don't care which one you do. 1 out of 5, that's the same as 0.2. Okay, that's our probability of success. Okay, what are the other things we need to know? Okay, probability of failure. We won't actually have to type that into binomial PDF, but let's write that down. Probability of a failure, that's that Q. So this is probability of a success. This is probability of failure. Okay, probability of failure would be 0.8, right? 4 out of 5. All right, and those add up to 1. Perfect. What else do we need to know? Number of trials. Now, what do you think number of trials means? How many people? That's our number. That's the big number. So n is what? 10. Okay? N equals 10. And we need to find the probability that exactly 3. So we're finding the probability that x is equal to 3. Okay? That's what we're trying to find. That x is 3. So x is our number of outcomes. So, like I said, you have to go to binomial PDF. And if you have the newer calculators, you'll type these in where they say. If you have an older calculator, you got to follow the order of what I said. And what did I say the order was? N, then P, then X. It's actually easy to remember. It's alphabetical order. So binomial PDF, you type in N first. Okay. N, then P, then X. So you're going to type in 10, and then 0.2, and then my X value is 3. Number of trials is 10. probability is 0.2, and my x value is 3, exactly 3. What did we get? 0.201, which is what I have on this slide. Okay? You should get 0.201. So there's a 20% chance that this is going to happen. Now, before you leave, okay, we are going to make the probability distribution for all the possible outcomes of this, just so that you see what's going on here. Okay? So I'm going to stop this.